In this section, M.2.2, you're going to evaluate the information in data sets, tables, charts, and graphs using statistics. So you're going to be using some of the same information that we just covered in section M.2.1. Statistics and data analysis are important parts of what many professionals do quantitatively. And on the TEAS test, it requires that you understand some basic concepts and carry out basic statistical calculations. So we're going to look over here at our objectives. It's going to calculate the measures of central tendencies, which is the mean, median, and mode, which you should hopefully already familiar with. Then we're going to determine the range. That means the minimum, the maximum, and the absolute difference. Then we're going to interpret the spread of a data distribution. We're going to identify the shape of a data distribution. We're going to identify and verify trends, finding in the relationships based on results of statistical analysis. We're going to identify expected and unexpected values or outliers. They will calculate probability to determine the likelihood of an outcome. The three measures of central tendency are the mean, the median, and the mode. You may be familiar with this, but if you're not, we're going to show you how to find each one of them. The mean is really the average. So to find the average, you add all the numbers in the set or list and divide by how many numbers are in the set. It doesn't matter if they're in order or not in order. The mean, you just add them up, then divide by the number of items. And the median, it's the middle number of an ordered list. So if the numbers are not in order, the first thing you have to do is put them in an order. So they are going from lowest to highest. Then if there are an odd number of terms, there's going to be one middle number. If there's an even number of terms, there are two middle numbers. So when you have this example, the mean of these two middle numbers is the median. So you can see an example here. And then the mode may be the easiest to find, but it's usually the one that's missed the most. And that's because of the definition. It says the mode is a number or numbers in a list that occur most often. If a list contains two modes, it is called bimodal. And you can see in this particular example, 3 is the mode because it occurs most often. Then we can look down here at our keywords, the measures of central tendencies, which we just covered. The sum is just really the result of addition. And bimodal is when you have two clear peaks, or in our particular case of here, we have two different modes. In your handouts is this example. A normal resting heart rate for adults ranges from 60 to 100 beats per minute. So the following pulse rates were recorded for a group of 15 students. And you can see this is not in an ordered list. I'll just randomly put the numbers. So what I want you to do is, I want you to find the mean of the list. And the way that you would do that would be just add all the numbers together and then divide by 15. So we got our mean was 72.8. Then to find the median, we have to first put them in order. So I put them in order from smallest to largest. And this is, we have an odd number, we're only going to have one mean. So there's 15 numbers. So the 8th number is the middle number, and the median is 71. Now to find the mode of the list, which is the most listed numbers in the list, I can see that 70 is listed twice, 71 is listed twice, and no other numbers are listed more than that. So I have two modes, 70 and 71, which makes this a bimodal list. So hopefully by using this example, you'll be able to find the measures of central tendencies, or the mean, median, and mode of any list that will be given in the TEAS test. Now we're going to talk about the range. The range is one measure of spread for a data set. And to find the range, just take the minimum value in the list and the maximum value in the list and subtract these two. Once you get this is called the absolute difference, meaning the absolute value. So for example, given the table for the mean, median, and mode, we had 14 minus 3, that's our max, this is our min, so 7 is the range. 11 is the range. Now standard deviation describes how data varies from the mean. A standard deviation that is very high indicates that it is spread out as far as the values, whereas a low standard deviation describes a data set where the majority of values are close to the mean. And then we have the shape of a data distribution. It can also reveal variable information. And noted below are several common distribution patterns. In this example on symmetry, a symmetric distribution can be divided at the center with each half mirroring the other. So if we go about where 50, 51 is, I can see about half the values on the left, half the values are on the right. And then the number of peaks can also tell you about the material. A unimodal is when there's a single clear peak. And when there's two clear peaks, it's called bimodal. So in this example here, I can see there's one basic peak. So this is a unimodal. And this is also called a bell shape. But if you look at this example, there's two different, you might say, high points. One is here, one is here, so this is called a bimodal one. Then you need to be familiar with some of these definitions down here. Most of them we've already talked about. Just make sure you understand what each one of them represents. Then we're going to talk a little bit about skewness. Now, some graphic distributions have more observations that fall on one side of the graph compared to the other. So if it's skewed right, that means most of the values will be on the left side. And so distributions with fewer observations on the right towards the higher values are skewed right. So skewed right means you have very few out here, but most of them are on here. Skewed left is just the opposite. You have very few lower observations, or the ones on the left, and mostly the ones are on the right. So basically, whatever your name is, just do the opposite, and that tells you where the most values are. Then we also have the uniform one, which is when the data sets are spread equally across the range of distribution. It's called a uniform distribution, and it has no clear peaks. So it's basically just same across, or just kind of scattered across at an even uniform data. Sometimes when you're looking at a graph, you can see what we call data trends. Data trends are usually easy to see in simple data tables like the one shown below. We can kind of see our data is kind of going up, except for this one way out here. Graphs are variable because they make trends easier to see, but a more complicated one may not be able to see this value. As we can see from our values of x, as the value goes up to a certain point, 6, our value of y goes up. Then once it gets above 6, the values for y start going down. And so we can look at this graph and see our expected values, or the ones that we expect to see in a graph. They're the ones right around the straight line, but the outliers, which is this one that's way out here, is an unexpected value that does not fit any trend or pattern in the data. You may have an outlier in some graphs, sometimes you may not have. But all the points in the graph fall along the trend line except this one outlier that is way above the rest of the data. So not all graphs will you be able to see a trend, and not all graphs will have an outlier. So once you understand what the trends are, that might be able to give you some information from a graph. The last thing we're going to talk about in this section is probability. And since data sets often contain information regarding events that can be measured numerically, when trends are identified, the information within the data can also be used to determine the likelihood of an event occurring if another data piece were to be collected. If you take a statistics class, you're going to be doing a lot with probability. But for the TEAS test, you're not going to have to get too much in depth in the probability or statistics. Now, simple probability can be found by dividing your desired outcomes by the total number of outcomes in the data set. So the probability of an event occurring is equal to the number of desired outcomes divided by the total number of outcomes. And this is an example. Students taking 12 math tests in a course, 8 grades in the 90, 3 grades in the 80s, and 1 grade in the 70. The data can be used to determine the likelihood that with equal preparation and level of understanding, their next score is going to be in the 90s. So probability currently 8. This is the desired outcome of her 12 test scores. That means she has 8 grades in the 90 divided by the total outcomes, which is 12. So the probability is 8 over 12, or 0.667, which is 2/3 or 66.7% likely that she would score in the 90s on her next test. So this is a probability. If you had a probability of you flip a coin and won't know what's the probability of getting heads, well, there's 2 outcomes. It's either going to be heads or tails. So to become heads, it's 1 out of 2. To become tails, it's 1 out of 2. So that's the way you might do probability on the TEAS test. Once you understand all the information about the graphs that we just went over, and also your central tendencies, which is the mean, median, and mode, that's the first practice point. And you will have different questions about your different graphs, as far as the shape of them, whether it's, you have outliers, whether it's increasing, decreasing, all that information. You should be able to do your practice problems. And again, I've worked out all these practice problems and posted them in Canvas. So good luck on this section.